Hi, this is Mr. Royks, and what we're going to do in this video is we're going to deal with titrations. So what I do, I have some equipment with me. To do a titration, you're going to use a burette. Basically allows you to add small, very small quantities of a solution to another solution. And so this is a burette clamp, and so this will hold the burette onto the ring stand. Okay, there's a clamp, and you're going to tighten that there. But there's a few things we need to do before we can get going with the lab. The first thing is we need to take some of the solution that we're going to be, that's called the titrant, which is basically what's going to be put in the burette. And we need to take some of that solution. In this case, we're going to be using some sodium hydroxide. This is a 0.1 molar solution. And we need to rinse out the burette with a small amount of this strong base. Reason why we want to rinse this out with the strong base is we don't want any distilled water in there. So we'll take a very small amount, you're going to put it in there, and then you're just going to rotate the burette back and forth, trying to make sure that you've coated the entire surface of the inside of the burette with that solution, your titrant solution. Then you can take a second beaker and you can pour the remaining solution into a beaker. So we've gotten rid of that extra solution. Okay. The next step is to put it on the clamp. You'll notice that there is a little valve down here. Right, when it is perpendicular to the burette, it is closed, and when you turn it parallel, it is open. And you can see there was a little bit of water from when we cleaned that. That just came out. And so once we've rinsed it, we're going to close that up. We're going to attach it to the burette clamp. And then once we've done that, we are going to carefully add our titrant solution, which, like as I mentioned before, is going to be 0.1 molar sodium hydroxide. So now that we have the burette in the stand, we are going to be using a small funnel to help us add the titrant to the solution. So I'm going to put the funnel in there, and then making sure the valve is closed, because that's very important. Valve is down here. All right, and it is, again, in the closed position, as you can see. All right, we are going to add the sodium hydroxide. Carefully pour the sodium hydroxide into our funnel. So as you can see right now, we have the burette filled with our titrant, and we're actually a little bit beyond the 0 mark, which is absolutely fine. We then need to come down here to put a waste beaker underneath the pipette valve there. So the end of the pipette. Waste beakers we're going to use quite a bit to just kind of help things set up. And by turning the valve, we can then allow a very, very small amount of fluid to come out. If you turn it all the way perpendicular, you're going to get a much stronger stream, and it's going to flow out much faster. So you need to just kind of get used to how the valve turns and how much fluid or titrant is actually going to come out of there. The other thing we want to make sure is we want to make sure that down here in the burette tip that there are no air bubbles, because air bubbles will affect the value or the volume of titrant we're using, so we shouldn't have any air bubbles there. Now that we've done that, we've made sure that this is all set. If we go back up top here, you'll notice that we're beyond the 0 mark. And my burette's not very straight. There we go. We're beyond the 0 mark. That is absolutely fine that we're beyond the 0 mark, because really the most important thing is we need to make sure we mark down where our value started at. The two important measurements that we're going to make on the burette is the volume at the start and the volume at the finish, and we'll be taking the finishing volume minus the starting volume to solve for how much titrant we actually used. Now that we have this, I have in this Erlenmeyer flask a small amount of hydrochloric acid, that we would measure this amount of hydrochloric acid, but we don't know the molarity of this acid. So that's the whole purpose of this titration. So then what we are going to do is we are going to remove the waste beaker, and we're going to put the flask, the Erlenmeyer flask, with our solution underneath the burette. Now what I will do is, in order for us to see this neutralization occur, we need to know the endpoint. So the endpoint is when we, in this particular case, when we get a color change. So I have a small amount of phenolphthalein right here. I'm going to add a drop or two of phenolphthalein to our acid solution. As we know from class, that phenolphthalein will not cause our acid solution to change color, but will only change color when there is a base present. So the whole purpose of this titration is to see whether or not our flask is going to change color. In saying that, one of the things that we might want to do is place a white piece of paper underneath our flask, because we would like to have be able to see even faint color changes. So now that we have everything set up, we're going to do what is called a mock titration, where we're not really going to do an accurate calculation of volume, but what this does is it allows us to kind of see where we stand and about how much volume it might take to get to that endpoint. So I'm going to open this up slightly, and I'm going to let this run. And we're going to watch this Erlenmeyer flask. And as this is running, hopefully we should start to see a pink color change in the flask. So far we don't see anything yet, but as the concentration of hydroxide ions starts to increase, we start to see that color change. And so you'll notice that if I swirl this, right, all of those hydroxide ions are reacting with the hydrogen ions inside our solution here, and now there aren't any left to react with the phenolphthalein. So I'm going to do this again. I'm going to let this run a little bit longer. And again, this is just a mock solution. So we're not really worried about the exact calculation here. And I'm going to swirl that again. Do that one more time. Now, one of the things in doing this titration is we do not want the solution to ever get this dark pink color. This dark pink color means that we have used way too much base, and we have way too much base present and not enough acid. So we're going to have to, when we actually do the calculation, or when we're recording the amount of solution used, we don't want to get this far at all. Now that we've tried our test run, we can again try this for real. Again, the important thing is we don't have to bring the solution back to the 0 mark. We just have to record where the solution level is at the beginning, and record it again at the end. So we're going to run this for real this time. And one of the things you need to, again, be careful with is the color change. You're going to be stopping this. Once you start to see a color change, you're going to stop it and swirl. All right, and you want that color to disappear. And the longer the color remains, the closer you are to that endpoint. So you can see each time I add a little more solution, the color is lasting a little bit longer. And that means we're getting closer and closer to the endpoint. One of the goals is to never get it to the point where I showed you before with our test run, where it was that bright pink color. That once you've passed the endpoint, the only way you can really get to where you want to go is you have to start everything over again. So you can see that color solution. I got it on a drip there. And again, you want it so it just barely gets a pink color. The pink color should be just visible on a white background and almost not visible on a black background. All right, and so when you've done this perfectly, you end up with a very faint pink color that is almost really, again, only detectable by the fact that you're working on a white background. And so what then we could do is record the amount of our final volume of the titrant and subtract that from the initial, and that gives us the volume of base used. We also knew the volume of the acid used, and knowing those three values, we can then solve for the concentration of the acid. And I'm going to show you, unfortunately, what happens if you go just beyond the endpoint, and it's a difference of really a single drip. So if we go a single drop beyond what we needed, we'll add one more drop, and you'll see that it makes a huge difference in terms of the color. And obviously we have a lot of base present here. And so a tiny, tiny amount makes a very big difference when we're doing titration. So this is now beyond the endpoint. Before that drop, we were at the endpoint or the equivalence point, and now we're beyond it. And we'd actually have to start this all over again, go through this titration all over again to get back to the appropriate endpoint. All right, so that's what we're going to be doing in class. I may add a few more notes on this, but there's titrations.